This is 8-7 Math, Lesson 100, Estimating Square Roots in Irrational Numbers. The first part is learning some definitions. What are real numbers and what types of real numbers are there? Real numbers can be split up into two categories, rational and irrational numbers. Rational numbers are numbers that can be expressed as a ratio of two integers, and irrational numbers are numbers that cannot be expressed as a ratio of two integers. These all follow under the umbrella of real numbers. There is something called imaginary numbers. They're not fake numbers, they're called imaginary numbers, but we don't need to get into that right now. So an example of a rational number is 7 or 1/3 or -8. All of those are rational numbers. An example of an irrational number would be something like pi, because it never ends, or something like the square root of 2. Both of those are pretty common examples of irrational numbers. So first we're going to talk in the first part of the lesson about how to estimate square roots. And what they're going to be doing is for you to narrow it down and say what two consecutive whole numbers does the square root fall between. The best way to get ready for that is to list the perfect squares. So I'm going to list in one column, I'm going to list the counting number, and in the other column I'm going to list its square so that I have that as a reference. So this will be the number, and this will be the number squared. So I have 1 squared is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is good just to have as a reference. 11 squared is 121, and 12 squared is 144. So if somebody were to ask me, what is the square root, if a number fell right here, what is the square root of 51? Well, it's a little bit bigger than 7 and a little bit smaller than 8. So we'd say that the square root of 51 is between 7 and 8. They are giving you the example of what is the square root of 200. Well, that means we need to keep going with our numbers. 13 squared. So it's bigger than that. 14 squared. And 15 squared is 225. Right. Double check. 225. So if they're asking you the square root of 200, the number 200 falls in this area between 196 and 225. So the square root of 200 is between 14 and 15. It's a little larger than 14, a little smaller than 15. Their other example is having you put some irrational numbers on a number line, and also to name which ones are irrational. So make a number line. This is example 2. The question says, sketch a number line and show the approximate locations of the points representing the following real numbers. Then describe each number as rational or irrational. I'm just going to make some spacings here so we have somewhere to start. The first number they have is pi, so we know that pi is 3.14159. It never stops. So pi is going to be here. The square root of 2, if you use your calculator, you would find that the square root of 2 is more than 1, less than 2. So it's closer to about here. It's the square root of 2. They want you to graph 2.3 repeating. So that is 2 1/3. and they want you to graph negative half, which is over here. If we need to say whether they're rational or irrational, this one is rational because it can be written as a ratio of two integers, 1 over 2. This one is also rational because it can be written as a ratio of two integers. If we wrote 2 1/3, we could write it as 7 over 3. So it's written as a ratio of two integers. The square root of 2 cannot be written as a ratio of two integers, so that is irrational, as is pi. I'm going to actually go over the practice problems D and E because they're a little bit tricky. D has a triangle like this for you, right triangle. Oops. It's an isosceles right triangle. I didn't draw it correctly. Okay. And they're telling you that one of the legs is 1, as is the other one, and they want you to find the length of x. So using the Pythagorean theorem, we know that 1 squared is 1, 1 squared is 1, and then we will know that the area of this resulting square must be the sum of 1 and 1, or 2, which means that the length of the side x is the square root of 2, which is irrational, so we're not going to approximate it. We're just going to say that the answer is x equals the square root of 2 and leave it like that. Unless they ask you for an approximation, don't do an approximation. And similarly, example E also has a right triangle. And on this one, they've left one of the legs off. This length is 1, this length is y, and this length is 2. So 1 squared is 1, 2 squared is 4, and we don't know this one. So we know that 1 plus y squared equals 4, which means that y squared equals 3, and so the length of y must be the square root of 3. And we'll leave it as that answer because 3 isn't a perfect square.